Yay, we're live.
All right, everybody, welcome to the 9th monthly installment of our virtual astronomical outreach presentations, a collaborative effort of the Riverside Astronomical Society and the Department of Physics and Astronomy at the University of California at Riverside. My name is John Liederbach Vega, and I am the Outreach Director for the Riverside Astronomical Society. I am not by any means a professionally trained astronomer, but I've been what you might consider a backyard astronomer for more than 30 years and just love it. And I'm coming to you live from my home in Riverside, California. And I will be one of your co-hosts for this evening. And our other co-host is...
It's me. Hi. Good morning. Good evening. Well, some of you might actually be there morning. Afternoon, morning, everyone. My name is Sinan Du, and I am in charge of public outreach in the Department of Physics and Astronomy at UC Riverside. My professional background is in astronomy, and I actually study galaxies that are very far away from the Milky Way. So today, we will actually be looking at a couple of them and to see how they are different in all different sense. So we're very excited to continue this collaboration with the Riverside Astronomical Society. It's already our 11th month running this program, and we are going to have our first anniversary in June. We started our first session on June the 25th, 2020. So today we will actually be exploring the spring night sky in a little bit detail, learning about different constellations and to be looking at various deep sky objects. So next we will have our lovely volunteers to introduce themselves, and they will be moderating the YouTube live chat, as you can see on the right-hand side of the YouTube page. So let's start with Garrett.
Hello. Hello, everyone. My name is Garrett Lopez. I'm a second-year graduate student at the University of California at Riverside, and I specialize in studying the very early universe. And I hope you all enjoy this show tonight.
Thanks, Garrett. And Yongda?
Hello, everyone. My name is Yongda Zhu. I'm also a graduate student at UC Riverside, and I'm studying the galaxy formation and evolution in the very early universe. So I'm very happy to answer your questions in the chat.
Thank you. And we have Jess.
Hi, I'm Jess Stoppel. I am a fourth-year PhD student at UCI, and I am studying the globular clusters that exist within galaxy clusters.
Very cool.
And I'm very excited to answer your question.
Thanks, Jess. And Franco?
Hi there, my name is Franco Iglesias. I'm a first-year graduate student at CSULA going for my master's in physics. Happy to be here. Hope you enjoy the show.
Thank you. And finally, we have Cheryl.
Hi, everybody. Cheryl Wilcox here from the Riverside Astronomical Society, part of their outreach program. And by day, I am a middle school science teacher. So welcome, and I will be helping with the chat.
Thanks, Cheryl. So all the other telescope operators will be introducing themselves when it's their turn. We welcome all kinds of questions in the chat and also encourage you to engage in discussions. So please be respectful to others since we are expecting a relatively large group here tonight. Most of the questions will be answered by our chat moderators directly in the chat, and the remainder of the questions will be relayed to the panel, and we will answer them live throughout the event. So this is our 9th Stargazing event, and we warmly welcome all of you who have been with us for a while, and it's always excited to see the newcomers every time. So we will certainly love to collect the feedback on how we did tonight and how we can improve based on your needs and preferences. So John, do you want to say a few words before we go on to talking about raffles?
Yeah, so as Sinan mentioned, we're going to be going deep outside our solar system tonight, looking at 5 different deep space objects. We're going to be looking at an open cluster of stars, a globular cluster of stars, a planetary nebula, and 2 amazing spiral galaxies. So we're going to show you a lot of pretty cool images tonight. So if you can, you want to switch over onto the biggest screen available to you. Hopefully you're not just going to be stuck watching us on your phone, because you'll miss some of the grandeur of the images we'll be able to show you. Yeah, and so we'll be looking at 5 different constellations scattered through the sky for these deep sky objects. And we'll be learning a story about an amazing little boy. So more to look, bunch of stuff to look forward to.
How exciting. Great. And finally, as the new format of our 2021 Stargazing program, you have the chance to enter a raffle at the end of this event. So our prize for today is a very beautiful NASA calendar provided by one of our NASA Solar System ambassadors, Jose Castro. Okay, let me pin your video, Jose, so everyone can see this beautiful calendar. Do you want to just quickly show everyone?
Sure. As Sina was saying, we're going to be sending to some lucky people beautiful calendars that NASA sent us in order for us to hand out to people that are interested on the science and space. So if you're a lucky one, you're going to be looking at 2021 with a lot better eye than you did at 2020. Thank you very much.
Thanks a lot, Jose. Yes, and as we talked before, next month is going to be our 1st anniversary, and we will raffle off a Celestron telescope. Anyone can enter the raffle at the end of that event. So we'll talk more about it at the end of this event, but that's definitely something to look forward to, so please stay tuned. And just before we get started, I would like to address something that many of you may have in mind. Why are we starting so late? I know this is almost bedtime for a lot of people. Well, we're now in daylight saving time, and we would have to wait, unfortunately, in some ways, for the sky to be completely dark before we can actually show you the live view of those targets, especially when some of the objects are relatively far away and they're relatively faint. So in order to achieve a better quality of viewing, we would have to start a little bit later. So thank you for your understanding, and we're very excited that you're here with us tonight. So without further ado, let's start.
Okay, so we're going to go out, and object number 1 that we're going to view through our telescopes is a swarm of bees. For reals. Well, kind of for reals. And Randy is going to take us there. Take it away, Randy.
Okay, very good. Let me get this going here and share a screen. And let's see, we should be getting something about here. Okay, I trust everybody's seen a page here with some stars and a star map on it.
Yes, we are.
Very good. Okay. First object that we have tonight is an easy object, especially if you're a beginning amateur or just kind of getting into this. It's called the Beehive. It's fairly bright, especially if you're in dark skies. You can see this easily with the binoculars. You can see this easily with a small telescope. And where would you look? Well, right now, if you look south, you would see Leo the lion. Here's his head and his hindquarters and his heart and paws out over here with the star Regulus. And you'll see a bright star over here, Pollux, and it's sort of in between. Pollux is part of the twins of Gemini. This constellation is kind of dim. It's Cancer the crab. Also, the Arabians used to consider this the whiskers of the lion, being the lion is over here. And the beehive was sort of between the whiskers, this fissure in between the fissures of the line over here. Aratus in 260 BC mentioned about the beehive in a poem, Heavenly Phenomenon. And Ptolemy in the 2nd century said the beehive star cluster is a nebulous mass in the breast of Cancer. Early Mediterraneans used to use this as a weather gauge. If you could see this with your eyes on a clear night, then you're probably going to have good weather. If it was nice and clear, but you couldn't see this, then that means that there was a prediction of a violent storm coming, because your sky was potentially getting very moist, and it was a precursor to a storm. The nice little bit of mythology about it is the Greek and Roman mythology. It was two donkeys eating in a manger that the god Dionysus and the companions Silenus rode into battle against the Titans, but the Titan was scared away by the donkey's brain. I guess these Titans aren't anything like Thanos these days in the current movies, but got scared away. So the donkeys were immortalized in the sky as a reward. Let me see here, go on here with this. Let me try the laser pointer here. It's one of the closest open clusters to the Earth. What you're seeing here is the cluster right about here, the heart of the cluster. Galileo was the first person to see this optically through a telescope, and he kind of noted about 40 stars. There's really about 1,000 in here. Some people see, like this little picture over here, this makes a kind of a cone-shaped image here, which is sort of like the beehive, and these bright stars are buzzing around the beehive. Or here without the picture in it. This is a live picture through not a big telescope, but actually a telephoto lens. It's through a 300 millimeter telephoto lens. And you can see the stars sort of twinkling as we go on here. But its distance is fairly close as stars goes, a little under 600 light years away. And the group that's bound together around about 1,000 stars are within about 39 light years across. Add them all up, they weigh about 500 to 600 times the mass of our own sun. They're all about the same age because they were born out of the same cloud of gas and dust. That's where the term open cluster comes from, because they're slowly spreading apart. And they're only about 600 to 700 million years old. However, there are a few stars in here that are already getting to their old age cycle because they're burning through their fuel faster. If you see some like this one here, and maybe one over here, and another one out over here that's kind of orangish. You can see a little bit better over on this side, these three stars. They're becoming red giants. If you're in the city, you probably won't have that great a look because you have city lights. I'm in Riverside, and there's quite a bit of lights. I have to use binoculars to be able to see this. One other thing I'd like to throw in here is I was getting ready for this, and to be prepared, I got a hold of made a video just in case it was cloudy. But I noticed in the video that I had for my backup, if you watch carefully, let me hit play on this, you'll see something go by here in about a second or two. There it goes. You notice it's jumping because the camera takes a picture every 2 seconds. It's not a continuous, like 24 frames per second or something. And that, what you just saw there, was not an airplane. It was actually a satellite. So while I was videotaping the cluster here, a nice satellite happened to come by just to kind of excite the picture up a little bit. Let me remove this. And let me go ahead and finish up here. Go on to the next picture. Okay. There we go. Here we have a couple last minute pictures. Here's some pictures by other people who are much better at this astro imaging than I am with digital. This one here is by KSU Astro, and they took some artistic license to it. And you see that they all have kind of sparks and it's kind of fuzzy around it. And it kind of brings out the color of the stars a little more. Here, a person by the name of Oliver Stein happened to get a beautiful photo of Comet Neat next to M44, the Beehive. And out of, I believe, the UK, we have Photogav, who got this beautiful picture here of M44 showing much deeper in and a lot more stars. And with that, I'm going to turn it back over to John and Zena.
Thank you, Randy. That was terrific. Now, let's see how well you guys out there know, how much you know about clusters of stars. We have questions for you.
Yes, we do. And our trivia question number 1 is actually all about star clusters. So first question is, do you think all stars in the same cluster formed at the same time? Just simple yes, no question. And if you feel that's a little bit too easy, here's a second question for you. How do you think that we determine the age of a star cluster? Yeah, so put your thoughts into the live chat, and after the next telescope target, we'll come back and reveal the answer.
All right, so let's get ready to go outside and look through a telescope. So what we're going to do is look in the northeast part of the sky. And there we will see the constellation Hercules. And Hercules is recognizable mainly because of this trapezoid type box that is called the keystone. And the keystone is the chest of Hercules. And you see his arms sticking out here, his legs going down around here. But paying attention to the keystone right there, we're going to find what's called a globular cluster of stars. Hundreds of thousands of stars packed together like a snowball or like diamonds on a black velvet cloth. And Jose's going to take us there.
All right. Good evening, everybody. My name is Jose Castro. I'm broadcasting from Moreno Valley, California. I also belong to the Riverside Astronomical Society. And tonight I'm going to be talking about a cluster of stars that it actually represents a jewel in the sky. Are you seeing this?
Yes.
Okay, so it's called the Great Hercules Cluster because it's actually in the constellation of Hercules up there. It's in the chest.
Jose, sorry, I don't think you actually started showing the slides. I mean, you could click the slideshow button.
Okay, hold on. What?
Yeah, you have a very cool animation. I know.
Well, yeah, but you don't see it?
You see a small screen. You don't have the full screen view.
Oh, my God. Hold on. Okay, let me start again here again. Okay, so can you see it now?
Yes, that
Yes, we
looks
can.
great.
All right, so there you go. So I'm gonna I'm gonna make an attempt of showing you people what over 100,000 stars. Some people think that as little as 400,000 stars or up to 1 million of stars are gathered in this cluster. And you are going to see the reason why. And as I said, you see here the constellation of Hercules. This is in the corner where you would see these cluster of stars. How you find it? Well, first of all, we're looking at stars that are grouped up somewhere around 25,000 light years from Earth, and it has an apparent magnitude of 5.8. And actually, this metropolis of stars in the constellation of Hercules can be spotted with a pair of binoculars, and especially during the month of July. If you are in a dark sky area, it's really, really visible at naked eye if you got good eyes. If you're like me, then you really don't. Probably won't see it. Now, Edmund Halley actually was the one that discovered Hercules cluster back in 1714, but it was Charles Messier, the one that added these as a comet, because that's what he used to hunt for, comets up in the skies, and but it wasn't until 1764 that the stars were actually resolved, and it was clear at that moment that there was no comet, but it was a bunch of stars bunched up together. You can start looking for these in the constellation of Ursa Major, right from the Big Dipper. You're gonna arch from the last star in the handle, and you're gonna go towards Arcturus. From Arcturus, you can jump onto Vega, which you can see right here, prominent. This is where Hercules is. This is Arcturus coming from the Big Dipper. And if you are gonna cross towards Vega, it's about 1/3 of the way down that you're gonna actually find out the cluster right here in this corner. Now, I was supposed to show you tonight a live view of the cluster, but since it's a little bit low on the horizon and I have some palm trees on my yard, I can show you the next thing. This was an image I captured last night. All right. So it's about 145 light years in diameter. It's composed of several 100,000 stars. Like I said, some people believe between 400,000 and 1,000,000 stars in this. It depends. You're going to tell me when you see the last picture that was taken by the Hubble telescope. All right. So in 1974, the Arecibo telescope, radio telescope, actually sent a message over to M13 in hopes of making contact with alien life. That is a really, really cool thing, thinking that the Arecibo telescope collapsed. So this is what the Hubble telescope actually saw when it decided to take a picture of the M13, or the great cluster in Hercules. And with that, I yield back.
All right. Thank you, Jose. So let's find out the answers to those questions about star clusters.
Thank you, John. Yeah. So, as some of you said, 1 second. Okay. So, as some of you said, all the stars in a star cluster actually do form at approximately the same time. But the thing is, when you have star formation, they won't all be the same. So some of them are much more massive, some of them are a lot bluer, some are redder. This is a good picture of like a young cluster. So you have a lot of blue stars. You have a good mix. You have blue stars, you have some yellow and some red. And the color and brightness of these stars is actually how we determine the cluster age. So stars spend 90% of their life on what we call the main sequence. So if you look at how bright they are and how hot they are, they tend to follow this trend, this line, and they spend 90% of their lives on this line here, on the main sequence. But the stellar lifetime is determined by the amount of hydrogen they have to burn. That's what drives star formation, is nuclear fusion of hydrogen into helium. So as these things age, these very hot blue stars actually go off the main sequence. The most massive bright stars have the shortest age, and as they come to the end of their lives, they enter this red giant phase. So they get so huge. Here's a good plot between, like, comparing the sun, which we think is like incredibly massive, versus a red giant star. So you get an idea of like how gigantic and huge these things are. It's actually pretty incredible. But this is what happens to a star near the end of its life. And like if we go to an older cluster and look at it and do the same plot, you see a lot of stars that were over here actually kind of migrate over here as they get to the end of their life. They become these massive supergiants, and they get very red. They're still very bright, but they're very red. And this is kind of how astronomers are able to tell how old a star cluster is, by looking at this sort of graph and seeing how many stars go how many stars are supergiants. And an example of a cluster that's very old is good old M80, Messier 80. So this is a very red cluster. So if you go and look and you kind of look closely, you see a lot of very bright red stars. And there's not a lot of blue. There's a couple small blue ones, but there's a lot of bright red. And that's how we know this globular cluster is very old. Okay. Yeah. So now you guys know how we figure out the age of star clusters.
All right, now it's my favorite, or at least one of my favorite times of our monthly presentations. Time for a story. Long ago, in a faraway land, a baby was born. Now, this was not an ordinary baby. His father was Zeus, the king of the gods. His mother was a mere mortal. Zeus was married to Hera, and she resented the baby that was born from her husband's infidelity. So she decided to kill the baby. So Hera sent 2 serpents to kill the child as he lay in his crib. But the boy strangled the beast with his bare hands. Not long after, the goddess Athena found the baby boy abandoned in the woods and took him in. She nursed the boy at her breast, and her milk gave him even greater strength and powers. The boy was named Hercules, and he grew up to do amazing things, and Hera would continue to plot against him.
After Hercules grew to be a man, he needed to serve the king for 10 years to earn his freedom. During this time, the king gave Hercules 12 tremendously difficult tasks to complete. These became known as the 12 labors of Hercules, among which we will feature 3 in this story. For the first of these labors, Hercules had to kill a monstrous lion that was terrorizing the residents of a nearby town. This lion could not be killed by mortals' weapons because its golden fur was impervious to attack. Its claws were sharper than any sword and could cut through any armor. When Hercules found the lion and shot it with his bow, he was amazed to see his arrows bounce harmlessly off of his fur. So Hercules had to come up with another plan. He lured the lion into a small cave and battled the beast with his club. Eventually, he was able to kill the lion by strangling it with his bare hands. The lion was taken up and placed in the sky as the constellation we now know as Leo.
So the king then sent Hercules to slay a terrible water monster known as the Hydra that Hera had created to kill Hercules. The Hydra had many heads, and if one was cut off, 2 would grow back in its place. So after cutting off many of its heads, Hercules soon realized he needed another plan. Hercules would cut off the head of the Hydra, and his nephew would immediately scorch the neck stump with a firebrand. Thus, the heads were not able to grow back. Eventually, Hercules was able to cut off the last of its heads, and the Hydra was defeated. Hera was furious that Hercules was able to defeat yet another beast she had sent to kill him. To honor the beast, she placed the constellation of the Hydra in the night sky.
After completing several more adventures, Hercules was given his 11th task. He was to steal one of Hera's golden apples from a garden which was hidden in the far western corner of the world. Anyone who ate one of these apples would live forever. Upon arriving at the garden, Hercules found the apple tree was guarded by a fierce dragon named Draco that was coiled around the trunk of the tree. Hercules was able to slay the dragon with a bow and arrow and retrieved a golden apple, thus completing his 11th adventure. Like the lion and the Hydra before him, Draco was also placed in the stars with his long tail coiled around the North Star and Hercules' foot firmly planted on Draco's head. And John will actually show us later where all these constellations are in the sky.
All right, let's go back out and check out looking through some telescopes. Now, here, give me a moment. As we were just now talking about the Hydra, the monster with many heads, we can find the Hydra, actually the largest constellation in the sky, but it is spread out, the stars are spread out over such a great length that it's really actually kind of hard to find the Hydra. But if we look at Leo, which we've been talking a lot about tonight as well as in prior nights, you can find Leo from this backwards question mark, and otherwise known as the sickle. And right down below that is where you find the Hydra. And right in the middle of the Hydra is a ghost. And Brian is going to tell us about that.
I am indeed. I'm going to go ahead and share my screen here. So here you have the view of the ghost of Jupiter, also known as NGC 3242, but I think ghost of Jupiter has a better ring to it. Now, this object is a planetary nebula. As John mentioned, it's in the constellation Hydra. Now, despite its name, the ghost of Jupiter has nothing to do with planets. This object is a nebula, and nebula is Latin for cloud. So this is a huge cloud of gas. Now, this was discovered by William Herschel back on February 7th, 1785. Now, let me tell you a little bit more about planetary nebulae. Such as the Ghost Nebula and others like it, they're formed when a star, similar in size to our own sun, approaches the end of its life and puffs out its outer layers. And this star, now, once it puffs out that layers, it actually shrinks down to the size of a white dwarf. And that's not visible in my picture, but in larger telescopes, you'd be able to see that center white dwarf. This looks tiny in my scope. And if I were to actually show you the view not zoomed, you could see that this is just a little blue fuzzy in a field of stars. And I'll actually bring up the brightness so you could see some of its other stars here. But let me bring back my presentation here. Now, while it's 2 light years across, it's far away. They estimate that it's about 1,400 to 2,500 light years, possibly up to 4,800. The estimates vary depending on who you ask. Here's a view from Hubble for the ghost of Jupiter. And you can notice that we have that center white dwarf star. You may notice something else about this image. We have these little red objects at the poles or the edges. These are believed to be younger areas of gas that are moving much faster than the majority of the nebula. So with that, John, I'll pass it back to you.
All right, thank you, Brian. Now, we're going to step outside because we can enjoy things outside without telescopes, without binoculars, without fancy cameras. We can go out and the sky will tell us a story just from looking up there. And the story tonight we're focusing on is Hercules. So we've already talked about Leo, the monstrous lion that Hercules had to slay. And that is in the almost directly overhead, what we call the zenith. And a little bit below that, we see the constellation Hydra that we just talked about and that Brian was just talking about. That's 2 of the monsters that Hercules had to catch and kill. And then if we go to a completely different part of the sky, low in the northeast, where we see the Big Dipper up near the top of your screen, and Draco the dragon right under it, this long, slinky little guy. You can find him by looking for his head, this box of 4 stars. And that's yet another monster that Hercules had to defeat. And then, of course, there's Hercules himself right next to the dragon. And you can see his foot here ready to stomp right on the head of the dragon. Hercules is feeling tough. So when you illustrate this, you see the dragon and his head, Hercules with his chest and his legs and his arms. And I don't know if you can see how well you can see this, but he's actually battling the Hydra here, several of these serpent heads. So the sky is telling a story. And this month, the story of Hercules is up there. So see if you can find those constellations. So now we're checking in with our chat to see what kind of questions are out there.
Great, we indeed got a couple of great questions. So first one is from Guadalupe Magana. So the question is, do you have to go to college to be an astronaut?
Yes, I'll answer that one, Sinan. And yes, Guadalupe, you do indeed need to go to college. In fact, they require what's called a master's degree, which is the next step after a bachelor's degree. And that master's needs to be in what's called a STEM field, which would be science, technology, engineering, or math. There's some other requirements that they branch out and some other ways they can help you qualify for that time, but you absolutely need to go to college. So keep studying.
Great. Thank you for the response, Brian. And here's another question from Harry Wan. If the closest open cluster is viewed in the past, say 2,000 years ago, versus 2,000 years in the future, what would you think of the changes of the outlines? Somewhat similar or spread apart evenly or unevenly or?
Yes. or option or D, all of the above. So your key part of that question would be open clusters. Open clusters, which are more spread out, are not nearly, or if all, gravitationally bound to each other. So over time, they do spread out more and more. Eventually, we may not even recognize them as a cluster, but simply stars, and that we could roll back time and see that they were closer together. And like you asked to do, roll out forward and we see them spreading apart. In fact, we think that there's some open clusters that used to exist that we no longer consider simply because they've moved so far from each other.
Yeah, great. Thank you, Brian. So John, I think that's what we got so far in the chat room.
All right, well, we need some other questions then, particularly questions for our audience about galaxies.
Definitely. Great. Let me grasp my slides. Okay. Awesome. All right. So this is the next question for you guys. Question number 2. Do you think all galaxies have similar shapes or appearances? Yes or no? And if that is, very easy yes/no question for you, then can you name some galaxy shapes or what we call morphologies? After naming those, do you know in what sense these galaxies differ from each other in each different categories? So put some of your thoughts into the chat and we will come back to reveal the answer after our next telescope target.
All right, so let's go out and look through some telescope again. And here, get rid of the images here. So again, we're looking in the north to the northeast part of the sky. And up near the top of your screen, you'll see what may be familiar to you, the Big Dipper, otherwise known as the Plow, depending on where you are in the world, which is part of the larger constellation Ursa Major. And you see the handle of the Plow, or the handle of the Dipper, right out over here. There is an amazing galaxy called the Pinwheel, and Manny is going to show us that.
So good evening, everyone. My name is Manny Lice, and I'm coming to you live from my observatory in lovely Mariposa, California, just about an hour west of Yosemite National Park. I'm a retired former engineering manager in the space business. I worked for a large aerospace company, and I've been a member of the RAAS, Riverside Astronomical Society, for several years now. But I've been an amateur astronomer for well over 30 years, and I've been a space geek ever since Buzz Aldrin and Neil Armstrong walked on the moon way back in 1969. Behind me, you can sort of see it a little bit in the upper left-hand corner of the picture here, is the telescope that I'm going to be using to show you the Pinwheel galaxy. This is an 11-inch Celestron telescope and has a cooled camera on the front. You'll notice that's a little bit of an odd arrangement. The light comes in the front of the telescope, bounces off the mirror, and then into the camera. So you're probably used to looking through the back of the telescope. This one is designed a little bit differently. And I have what's called a mount, which is tracking the night sky to keep our objects centered in the field of view. And so without further ado, let me take you to an image of Messier 101, and it looks a little bit funny here. I'm going to see if I can adjust the color on it a little bit to not make it look quite so red, but here it is. Let me zoom in for you a little bit. So this is a live view of the Pinwheel galaxy, and the Pinwheel is in the constellation Ursa Major, as John mentioned. It's what we call a face-on spiral galaxy. And so you can see let me see if I can adjust it a little bit here. It just wants to be red. I don't know what I do. But you can see this kind of a pinwheel shape, and you can see also a satellite that's whipping through there. But all these spiral arms whipping around. The pinwheel was discovered way back in 1781 by Pierre Méhain, and it was the 101st entry in Charles Messier's list of things that are not comets. It's 21 million light years away, which probably seems like a long distance, but actually that is comparatively close as galaxies go. It's about 170 light years across. The Milky Way, it's about the same size or so as the Milky Way. It has, so you've heard about globular clusters that we talked about, 100,000 stars, maybe 1 million stars. This galaxy has 1 trillion stars. So think about that this galaxy, this little tiny spot on the night sky, has more stars in it than all of the stars that you can see in our night sky in the Milky Way. So there are about 150 globular clusters. You've heard about globular clusters tonight. There are about 150 of them in this galaxy, around the same as in the Milky Way. And if you remember, the title on my presentation was Island Universe. And so if you think about this, I kind of look at this as an island, and the Milky Way is an island, because we are all traveling together, this group of stars. And the distances between galaxies are so immense, tens, hundreds of millions of light years sometimes. And so each one of these galaxies truly is like an island unto itself. So you'll notice here, it's a little bit hard to see in this picture, but there's a kink here in this spiral arm. You'll see it in a picture that I'm going to show later a little bit better, but that is due to an interaction that the galaxy had with some of these other galaxies. And if you may notice, as I zoom out here, that there are fellow travelers in the field of view here. Here's a little spike, and then here's a little blob, and here's a little blob. These are all other galaxies that are companions in the neighborhood of Messier 101, the Pinwheel. And as in most galaxies, there is a black hole at the center of this galaxy that is swallowing up stars that get too close. And all of the little bright knots, if I can zoom again, these brighter areas here are star forming regions where even today, the hot gas is collapsing to form new stars in the galaxy. So there have been, over the years, 4 supernovae that have been discovered in this galaxy, Messier 101. There was the first one discovered in 1909, another in 1951, a third in 1970, and the most recent one just about 10 years ago in 2011. And let me take you now, let me go on back. Here's a picture that I took earlier, and you can see some of these other galaxies. New General Catalog number 5474, 77, 73, and 22. I like this one here, the little edge-on galaxy. And there are actually 3 more that are in the background behind Messier 101 itself. So it's quite a little zoo, kind of a galaxy zoo. We'll be talking about that next month, I think. So onward, let me take you to a much better image than I can show you tonight. This one was taken with the Hubble Space Telescope back in, I believe it was 2009. This is a composite of 51 individual images, all put together, and included some images from ground-based telescopes. And you can see some background galaxies. You can see these star-forming regions and the distorted kink I was talking about earlier. So there it is, Messier 101, an island universe, and a really cool galaxy, I think. Let me hand it back to Sinan, I think.
Give it to me.
Okay, John, if you must.
All right. So what are the answers? Now you've all had a chance to think about those answers to the questions of the galaxies. Let's see what the answers are.
Yonda, it's your turn. Yonda, you might be muted.
Oh, sorry.
Yeah, your slides look fine though.
Okay, can you hear me right now?
Yes,
Yeah.
yes, we can.
And so you can also see the slide?
Yes.
Okay, so for this question, I have seen most of you got the correct answer in the chat. The short answer is no. Galaxies have different shapes, and you can see in a real image taken by the Hubble Space Telescope that there's a variety of galaxy appearances. And in astronomy, we classify galaxies using the Hubble tuning fork, a galaxy classification scheme proposed by Edwin Hubble. And from the left to the right, Hubble described these galaxies as elliptical galaxies and spiral galaxies. For the spiral galaxies, you can see someone has bars and someone doesn't. And there are also irregular galaxies, which are not shown here. Hubble also called the elliptical galaxies early type galaxies, meaning that he thought they were progenitors of the late type galaxies. That is to say, the spiral galaxies. But we now know that there's no evolution from the elliptical galaxies to spiral ones along the Hubble tuning fork. So as for the second question, as we just mentioned, galaxies are classified into elliptical galaxies, spiral galaxies with or without a bar, and irregular galaxies. Elliptical galaxies can vary greatly in size and mass, but typically contain primarily old stars. There are very little star formation in these galaxies because there's no much available gas to form new stars. On the other hand, spiral galaxies and irregular galaxies, they have enough gas and are actively forming new stars, especially in their spirals and in these patches. Well, irregular galaxies do not have a definite shape and are usually merging galaxies just like this one. overall, nowadays, the formation and evolution of different galaxies are still a frontier topic in astronomy. That's it. Thank you.
Thank you, Youngda. That was great. Okay, we're going to go up outside one more time and look through one more telescope at one more galaxy. And this galaxy, well, let's wait a minute here. We're going to look high up in the sky, almost at the zenith. You'll see Leo the lion. It seems like everywhere we're looking, there's always Leo. Here's Leo. And then here's the zenith. I don't know if you can see that little green Z. That means straight up above your head. And here we see this little kind of L-shaped or triangle-shaped group of stars, not very remarkable at all, known as Coma Berenices, which stands for, represents the hair of the queen, which is a whole nother story. But what we're looking at here is not just any galaxy, but a galaxy with a black eye. And Amanda will take us there.
Thanks, John. So hi, everyone. My name is Amanda. I'm a graduate student at the University of California, Riverside, studying massive clusters. Today, I'm coming at you from the Chicagoland area, but operating a telescope in Sonoma, California. The marvels of today's technology are great. So let me show you, before I get started, the telescope that we're going to be looking through or using to look at the Black Eye Galaxy. And it's called Stone Edge Observatory. It is completely remotely operated. Again, I'm able to operate it from the comfort of my own home. And it is a 0.5 meter, so pretty decent size or pretty powerful telescope. Again, in Sonoma, California, where the weather is nicer than Chicago. So this is what it looks like. Again, it is completely remotely operated, and it has a bunch of interesting quirks that we won't go into today, such as filters, but definitely tune in for another session because it's important for other objects, not so much for this one. And let me also show you the telescope from the inside. So this is it during the daytime, and here it is during the nighttime, i.e. right now. Let me turn the lamps on for you so that everyone can see it. Okay, so there you have it. That is the telescope. I just turned the lamps on and you can see that the slit is open. So we are good to observe. So before I actually observe, let me turn the lights off because that's an important detail. Okay, let me show you the way that I look through the telescope, or the way that we can get the telescope to take images for us. So we use a Slack interface for this, and we have a bot basically that controls the telescope. And today I'm going to be, as John mentioned, going to be showing you Messier 64, otherwise called the Black Eye Galaxy. So before I start telling you about it, let me actually take the image because while we wait for this telescope to collect the photons from this very distant object. So the way we take the image here is we do /image for 30 seconds in the clear filter so that we can get the most amount of light possible. So while that is exposing, the Black Eye Galaxy itself was discovered by Edward Pigott, who was an astronomer, an English astronomer who was one of the founders of variable star science, which is still important today. And he discovered it in the 18th century, actually a year before Messier, who this object is actually a part of Messier's catalog, even though it wasn't discovered by him. I feel like this is a recurring theme. So while this exposes, you'll see in a second why it's called the Black Eye Galaxy, and just on time. Very good. So unfortunately, the sun isn't that low yet. We start to observe at around astronomical twilight, which is when the sun is at -18 degrees under the horizon. But you can see why it's called the Black Eye Galaxy. It's also called the Sleeping Beauty Galaxy as well. The most remarkable feature, and this galaxy is super interesting, and the most remarkable feature about it is this dust lane over here. It actually has two dust lanes that are counter-rotating, which means that The inner part is moving one way with gas and stars, and the outer part is moving the other way. And this doesn't normally happen in galaxies. Usually you have them moving in the same, that you have the whole galaxy rotating in the same direction. And it's probably because of a merger that happened over 1 billion years ago that caused these two parts of the galaxy to rotate in opposite directions. And at the interface of where the dust lanes are counter-rotating, there is a lot of star formation because all of the gas is being compressed and collided and contracted to form stars. So this galaxy is actually really cool and has a lot of interesting dynamics in it. So this is just a 30-second image in the clear filter that I took. But if we had a little bit more time and a little bit darker skies, and we can create a color composite, there's a lot of caveats here, this is what we might see. So here is a picture of the same galaxy with 300-second exposures instead of 30 seconds in 3 different filters, which look at 3 different wavelengths of light. And when you combine them together, you get something that looks like this, which is something close to what our eye might see. So this is all very cool. But if you also happen to have a space telescope on hand, such as the Hubble Space Telescope, it would look like this. So dramatically different, and you can see a lot more detail. Again, here's the dust lane. Here are a bunch of the blue stars, which are new stars. We learned about this earlier, thanks to Garrett's presentation. New stars that are being formed, and also some red patches of gas that is being heated up by those very energetic blue stars. So that's the Black Eye Galaxy, really cool galaxy, has one of the highest surface brightness galaxies that we can observe today. So that's it. Thank you.
Thank you, Amanda. Awesome. Now we're actually going to go back in time a little bit. Remember earlier tonight, Jose was taking us out to look at the Globular Cluster in Hercules, but because of the palm trees and such, he wasn't able to get a good live view. Well, Brian has a good live view of the M13 Globular Cluster in Hercules, so we'll check that out.
I do, John. And so here we have M13, that globular cluster. And I like starting with this view. My favorite thing about this globular cluster is that the more you magnify, the more stars you get to see. So let's go ahead and zoom in. And see, so here's a much closer view of M13, some wonderful globular cluster. And so I'm glad that we got a chance to show you a live view of that tonight.
Terrific. Like a big snowball.
Yes, indeed. All right, pass it back to you.
Thank you. Sanan, how are we with the chat room?
Oh, we got tons of great questions. So we're going to have a very good discussion here. So starting from the first question from Hanai. So the question is, what bonds held those stars and all other heavenly bodies in their relative positions? So I can take a crack on that. Well, the first answer comes to mind is all they have, or all the kind of interactions they have with each other, is through gravity. So gravity only become prominent when two bodies are relatively close to each other, but even they're so far apart, there is still very, very tiny gravity in between them. However, for example, if we're talking about stars, then stars, they are, if we're looking directly in space, right, from a space kind of point of view, they're actually moving. Say the stars that are on the spiral arms, or like in a disk galaxy, they are rotating all together with the disk. So they're not just like staying in there themselves. Stars in clusters, they are also gravitationally bounded. So there would be some random motions with respect to each other, just because, you know, they can be scattered and be affected by other stars. But in general, those motions are not very apparent because we're just so far away from them. So they're not necessarily, held in place. They're moving, but we just cannot detect, or at least cannot detect by naked eye, that they're moving. So hopefully that is a satisfying answer to you. So moving on to the next one. Emma Gochomo asks, my 9-year-old daughter was wondering, why is it called a ghost of Jupiter if you know it is a cloud?
That is a very good question, and I'm happy to answer that one. And I should have brought that up when I gave my little presentation. We need to remember that this was a long time ago when William Herschel actually was looking at this object in his telescope. And he had already seen Jupiter. He saw a circle that had a crisp edge and some color to it, sometimes even just a little bit of blue. And then when he saw this planetary nebula, it was also similar in shape and color, but it was fuzzy. So I think that that's part of why, just like we might think of a description of a ghost being somewhat foggy or ethereal, he saw this image and said, it kind of looks like Jupiter, but it's fuzzy. So we'll call it the ghost of Jupiter. Or maybe he just did it to confuse us. So we talk about a planetary nebula named Ghost of Jupiter, and it has nothing to do with planets.
Thanks for that, Brian. So next question is from Deborah Myers, asking, can movement of the spiral pinwheel arms be detected?
Okay, I can take that one. So the answer to that question is yes. And the arms of spiral galaxies, of course, as the rest of the galaxy, they are made up of stars. And those stars have spectral signatures. So think about that as if you put sunlight through a prism, you see it spread out into different colors. And from the different colors in a star's light, we can figure out which elements the stars are made of. So this is why you need to go and take your physics and astronomy classes, because you will learn so much about this. But in a nutshell, think about it this way. You can detect by the way that the colors shift in the starlight, we can tell if those stars are moving toward us or away from us. And so that shift in the color of the stars, kind of like when a car drives by you, a race car, and it goes, meow. That change in frequency, the colors change the same way too. And from that, we're able to determine if stars are moving toward us or away from us. Now, in the pinwheel, maybe it's hard because it's face on, but think about a galaxy that's tipped, and some of those stars will be moving toward us and some will be moving away. And the ones that are moving away are shifted to the red, to the longer wavelengths, and the ones that are coming toward us are shifted more to the blue. That shift tells us how fast they're going and can tell us about how the spiral arms are rotating. That's also important because from that we can learn about the mass, how much material there is in the entire galaxy. And from that we can start to determine how big the black hole might be, whether or not there's dark matter, but there's a lot more to it there. So I'll leave that one there.
Thanks, Manny. And the next question is actually kind of related to what you just mentioned, the black hole. So Tosin, 9 years old, was asking, is there a hole in the middle of the Milky Way galaxy?
Yes, Tosin, and I believe when you say a hole, you're probably talking about a black hole. And the answer is yes. Just like most galaxies, the Milky Way does indeed have a black hole in the center. But don't worry, we're a long way from the black hole in the center of the Milky Way. So we're not ever gonna fall into it. But that is where a lot of the mass of the Milky Way galaxy is. And there are stars that are orbiting that black hole. And we actually have some video. You can go out on the internet and see some video of those stars orbiting the black hole at the center of the Milky Way. So yes, absolutely, the Milky Way has one, but we're safe. Don't worry, we won't fall in.
Thanks, Benny. And the next question is coming from Rosie Smith in Scotland. Hi, panelists. Do any of you have a favorite galaxy? If so, why?
Okay, I'll take
I love
that.
the Andromeda Galaxy because it's big and it's beautiful and it's 6 full moons across on the sky. It's enormous.
Manny, you stole my galaxy. That was the one I was going to take.
I got in before you.
Yes, you did. I was going to say the Andromeda also because it was the first one that I was ever shown when I got into amateur astronomy. It was the first one that I ever tried photographing back in the days of black and white film.
I like the Milky Way galaxy.
Tom.
You can see it. You go out to a dark place and you can just see it going from one end of the sky to the other. It's beautiful.
I myself, I love the Sombrero Galaxy. Check it out.
Thanks, guys. And here's our final question from Arnav Gupta asking, wouldn't the hot gas go on to decrease the rate of star formation? From what I know, from what I know, cooler gas forms stars faster. So I can answer that. That is absolutely correct. So this question, I see the question a little bit out of context, but in whatever situation you're talking about, yes, stars can only form in very dense, cold molecular clouds made of hydrogen. So say if you have like a supernova explosion and the gas near it is very heated up, or say like when we have a planetary nebula and those gas is also extremely hot and tenuous and emitting a lot of like different colors of light, it may take a while before they can actually start to form star again. So at least they would have to radiate all the energy, cools down, and to become cold and dense again before they're able to form stars again. But whatever heavy elements that are already there in the very hot gas, they will be later picked up by the next generations of stars. So I hope that's a satisfying answer to your question.
Okay, is it time to wrap things up?
It is.
All right. Let me just put in a little plug for my club, the Riverside Astronomical Society. If you are still watching us at this time, then my guess is you're pretty interested in astronomy. And if you're interested in astronomy, you might want to look around wherever you are. Certainly if you're in the Riverside area, Southern California area, there is an astronomy club waiting for you. But pretty much anywhere you are, I would guess, in the world, there are astronomical societies, astronomy clubs, where you can go and learn about cool stuff, share experiences with a hobby that you're interested in if you're watching us. So the Riverside Astronomical Society, its website is right here, rivastro.org. It's a group of maybe 300 or so people that think astronomy is cool. We're not professional astronomers. Not even all of us, we don't even own telescopes. But if you think astronomy is cool, join us or join some other astronomy club nearby.
Thank you, John. And following that, I will actually have my own plug for UCR Astronomy. So one way you can follow us is actually on Facebook. If you have a Facebook account, simply type in Astro UCR, and this is our page. So whenever we have an outreach event scheduled, you will definitely see a Facebook event. For example, this is our next event, the first anniversary one. And we also have astronomy lectures. And we also have specifically, sessions specifically for K through 12 students. So we have all kinds of programs. This is one way to follow us, or you could simply, choose to sign up for our email list when you receive the survey. Or some of you may also know that we have a website. If you search UCR Astronomy Community Outreach, we also have a very nicely built website that you can directly see what events are coming up. So John, would you like to share a little bit about other astronomy resources?
Sure. So let me share my screen again. So So again, if you are interested in astronomy, there are all kinds of resources that are available to you. There are some excellent magazines that come out every month to keep you updated on the latest and the greatest developments in the science and the hobby. Two of those are Sky and Telescope and Astronomy Magazine. If you don't want to subscribe to it, you just run down to Barnes & Noble and pick up a copy whenever you feel the urge. On the right side of your screen are a couple of excellent books about astronomy. Night Watch by Terence Dickinson. Tremendous book, is an introduction to the science and the hobby of astronomy for young adults. And then at the bottom right of your screen, A Child's Introduction to the Night Sky. As you might guess, it's a great children's book teaching all about how telescopes work and stars and galaxies and such. So those are excellent resources. And then there's also an app, as you've seen me go out tonight and show you the night sky on our screen. I'm using the Stellarium program. It's free download for your computer. Sky Safari is an excellent app for your tablet or your phone. And skymaps.com is a terrific resource where you can go to the website every month and download a free map of the sky that'll show you what's up in the sky that month. Where's Jupiter that month? Free, an excellent way to learn the sky.
Well, thank you, John. Is it already raffle time?
Which raffle?
Which raffle? Well, this time, for now, we're raffling off NASA calendars, 3 and 304 NASA calendars, and I have just put the raffle link in the YouTube chat. So all we need for now is just your name and email address that you use to sign up for this event. So if you win the raffle, we will contact you via email and arrange the shipping. So remember, the NASA calendar is not the only thing that we're raffling off in this program. So next month, we will actually have our biggest telescope raffle. And Jose, would you like to share a picture of the telescope that we're giving out?
Ooh.
Wow. I want this. Yeah, so one thing to note is because this telescope is really big, so unfortunately we can only arrange local pickup. I mean, but you don't have to be local as long as you can pick it up yourself. So this is the biggest upcoming raffle prize that we're gonna have. So stay tuned and remember that you know, our next event.
Can I say something?
Yeah, go ahead. Go ahead.
All right, before we wrap this up, if you win this telescope, you don't need to be an expert. As you can see, there is a smartphone in the cradle, and that means that you use an application in conjunction with this, and those yellow arrows that you see pointed up at the sky actually are gonna tell you in the application, as you see in that small screen, where the telescope is actually pointing at. So whenever you find an object in the sky and you go up to the eyepiece, whatever you're pointing and it tells you on the screen, that's what you're gonna see when you look through that eyepiece. Thank you.
Wow, how exciting. Thanks, Jose. So this is our, you know, one of our biggest thing for next month. And our next event will actually be on Thursday, June the 10th. We will be having a special session called the Galaxy Zoo, showing all types of different galaxies in the universe. So get ready for that. Oh, by the way, as we're going into summer and the sunset is getting later and later, right? So unfortunately, we cannot start until 9 Pacific Daylight Saving Time next time. So sorry if you would have to, you know, stay up a little bit late to join us, but we do appreciate that you're here with us.
Maybe you could take a nap earlier in the day so you can stay up late.
Well, that's a good idea, John. So any final thoughts? Any final thoughts before, you know, we wrap things up? All good?
No.
Great. Well, I would like to thank everyone for joining us tonight. As mentioned earlier, we would really, really appreciate your feedback on our show tonight. And you'll also have a chance to sign up for the email list that we have to be informed of all our upcoming events. So we will be sending out the survey tomorrow. It's completely anonymous, and we will only be seeing the statistical results as well as your comments. So I guess that is for today. Thank you all for joining and staying with us this late. We will see you next month, June the 10th at 9.
Be there or be square.
Bye, everyone.